Hello everyone, this is Swati from Aeronautical Engineering. Today we are here for a seminar topic on a subject called aircraft stability and control. So, here is the seminar topic. Speed stability, the difference between jet and prop. So, here comes the introduction. Speed and stability are two of the most important factors in aircraft performances. They decide how fast and how safely an aircraft can fly under different conditions. Jets and props, aircrafts known as props, differ greatly. In this area, jets are known for the high speed and smooth performances at high altitude, while props are slower but more stable and efficient at low speed. Understanding the difference between the two helps engineer, pilots, and designer create an aircraft that meet specific needs for commercial, military, or training purposes. Basic works of aircraft jet. Jet aircraft operate using jet engines that push air through combustion at very high speed. The engine compresses air, mixes it with fuel, and burns it to create thrust. It allows jets to move very fast. Often at supersonic speed, jet engines perform best at high altitude where air resistance is lower. They provide smooth, continuous power and make longer distance travel faster. However, this helps power comes at the cost of fuel efficiency and stability during certain phases of flight, especially at lower speed of during takeoff and landing. Basic working of propeller aircraft. Propeller aircraft use rotating blades driven by piston or turbine engines to create thrust. The spinning propeller push or pull air backward, moving the aircraft forward. Props are generally even slower, slower than jets, but offer control, especially at lower speed. They perform well at lower altitudes, are commonly used for short distance level training and cargo operations. Propeller aircraft are most fuel efficient and cost efficient for shorter routes. They also tend to be more stable during slow maneuver takeoff and landing, making them easier to handle on new pitons. Speed characteristics of jets. Jets are designed to fly at high speed, often above 800 km per hour, and can even reach supersonic levels in military applications. Their engines generate high thrust, allowing them to climb quickly and cover long ranges in less time. This makes them ideal for passengers airline and fighter jets. However, at high speed also increases aerodynamic stresses, which can affect handling and stability. At lower speed, jets may feel less stable and requires more advanced control systems. These speed advantages must be balanced with design features that ensure safety and control. Speed characteristics of props. Propeller aircraft usually fly between 200 to 500 km per hour. This slower speed makes them ideal for low altitude missions. Slightly cargo delivery and training, the lower speed allow better control, smoother turns, and more time for pilots to react to changing conditions. Through slower, they are more fuel efficient and less expensive to operate. This day performances is best and shorter routes or areas where jet aircraft cannot operate efficiently. The propeller design limits top speed because the blades lose efficiency at high rotational speed, creating more drag and reducing forward thrust. Stability in jet. Jet aircraft really on aerodynamic design and advanced control systems to stay stable at high speeds. Their wings and tails are shaped into manage the flow of air efficiently during fast flight. Stability at high speed requires carefully balance between thrust, lift, and drag. Modern jets are computer-assisted flight control system to automatically adjust control surfaces for balance. However, jet can be less stable at low speed or with turbulent air because they, they really move on aerodynamics flow. The propeller-driven thrust maintaining smooth flight requires careful designs and precision pilot input. Stability in propeller aircraft. Propeller aircrafts have natural stability because of their slow speed and simpler aerodynamic forces. The rotating propeller creates a gyroscopic effect that helps balance the aircraft. That slow airflow allows the wings to control surface to respond smoothly to pilot input. This makes flights easier to control during takeoff, landing, and turning. Their low speed also means less sensitive to turbulence. However, propeller torque can cause slight rolling movement. The pilot must correct overall propeller aircraft are considered more stable in low speed conditions than jet powered aircraft. Aerodynamic design differences. The aerodynamic designs of jet aircrafts differs based on their purpose. Jet aircraft have sleek, thin wings to minimize drag at high speeds. Their bodies are streamlined for supersonic and transonic flights. Propeller aircraft have thicker wings with more surface area to create lift at lower speed. The placement and high size of engines also affects aerodynamics. Jet typically have engines mounted under the wing or on the rear fuselage, while crafts have engines on the nose or wings. This design chooses greatly influence speed, stability, and performances across different flight conditions. Efficiency and fuel usage. Fuel usage varies greatly between jet and props. Jet consumes more fuel due to the high thrust required per speed, but they can efficiently at cruising altitude above 3,000 feet. Propeller aircraft, on the other hand, use less fuel at lower altitude and speeds. For short routes or regional flights, crops are more economical in constraint for long distance travel. Jet save time despite higher fuel cost. The choice depends on the mission. Jet or fast travel at high altitude drops for fuel efficiency, low speed of operations. Operational altitude jets are designed to perform best at high altitude where thin air reduces drag and allows greater speed. Commercial jet cruise between 30,000 to 40,000 feet ensure smooth flight and less turbulence. Propeller aircraft performs better at lower altitude, typically below 15,000 feet. They also loses efficiency at high altitude because the thinner air reduces propeller thrust. The altitude difference affects both performance and comfort. Jet aircraft experiences less resistance, while propeller planes are more so suited to short routes, rescue missions for agriculture and cargo purpose at low levels. Maneuverability. Propeller aircraft generally more maneuverable at low speeds because they respond quickly to control inputs and can turn within smaller areas. This makes them excellent for training and short field operations. Jet aircraft, however, rely on high speed and aerodynamic control surfaces. For maneuvering, they are less agile at low speed but can perform sharp maneuver at high velocity with the help of computer control system. Fighter jets are specially designed for such movements. In general, propeller planes handle better in slow flight while jets excel in fast and high energy flight conditions. Noise and vibrations. Noise and vibration levels differs noticeable between jet and props. Jet produces a strong continuous roar due to high energy exhaust gas, while propeller plane generates a rhythmic vibration from spinning blades. Propellers aircraft tends to be noisier inside the cabin at lower speed, but jets are louder overall. Near airports, modern designs and installations have reduced both noise types. However, vibration is usually less in jets at cruise speed, improving passenger comfort. Propeller vibration can affect stability and component life. So engineers work to balance propeller systems carefully to reduce it. Safety and control. Both jets and propeller aircrafts are safe when designed and operated controlled correctly, but their control characteristic differs. Jet depends more on automated system for stability, especially at high speed. Propeller aircraft allow more manual control, giving pilots a better feel of aircraft in emergencies. Planes can glide longer and land safety at slower speed. Jet aircraft, through more complex, have multiple systems for overall props are considered safer for beginners, while jets require more experience and advanced technology for safer stability operations. Environmental factors. Performances is becoming more important in aircraft design. Propeller aircrafts are more eco-friendly due to their fuel efficiency and lower emissions. Jets, while faster, consumes more fuel and releases more greenhouse gases. However, new jet engines are being designed for cleaner combustions and better efficiency. Propeller planes are ideal for local transport and cargo in rural areas with minimal environmental impact. Jet remains essential for global travels and defense, but continuous innovation aims to reduce their carbon footprints while maintaining speed and stability. Advantages and limitations. Jets offer unmatched speed, range, and altitude performances, making them ideal for commercial airlines in military applications. However, they are expensive, less fuel efficient, and needs long runways. Propeller aircraft are affordable, stable, and efficient for short distances, but lack speed capability, which tires serves a unique purpose in aviation. The key difference lies in how speed affects stability. Jet needs an advanced system for control, while props depends on simpler natural aerodynamic balance. Understanding these advantages and limits helps engineers choose the better and best aircraft type for each mission. Conclusion. The difference between jet and propeller aircraft in speed and stability shows how design serves function. Jet achieves high speed and altitude using powerful engines and advanced system, while props offer better control, efficiency, and reliability at power speed. Each design type plays a vital role in modern aircraft. From long distance travel to local missions, the balance between speed and stability depends on purpose, environment, and technology. As aircraft design evolves, engineers continue to merge the best feature of both systems for safer, faster, and more efficient flight. So, this is the rational design of lightweight propeller shaft. For the complex problem, we have shaft and the propeller design with a lightweight and composite material. Thank you.